All right, greetings everyone. Now, look, what we are going to be basically looking at now is the concentration of a solution, right? Now, I think it is fundamentally important that first we understand what is our word solution. So basically now, solutions are basically your homogeneous mixtures, right? Homogeneous mixtures of which comprises of your solute and also your solvent, right? And what you need to know importantly is that your solvents and also your solute can be given in terms of gas, your liquid, and also your solid. And now the most common solvents that we know is liquid water, and that's why this we call it your aqueous solution. Now, which means therefore your aqueous solution is going to be your liquid water. So, for example, now let me just give you the narration of your what is your solute and also what is your solvent. Now, let's say basically you are given that you have what we call your salt water, right? If let's say you have your salt water, now if you have your salt water, what you need to know is that now your salt in there, it is going to become what we call your solute, while now your solvent, it is going to become your what? Your solvent is going to be the water. How to get? So now another example would be if let's say you are given that you have what we call your soda water. Now, if let's say you have your soda water, what you need to know importantly is that now your carbon dioxide, which is your CO2, it is going to be your solute, and now your water again, it is going to be your what? Your solvent. Altogether. So basically, the solvent is what we use to dissolve our solute. Altogether. So now that's what we need to know in terms of your solute and solvent. Now, let's come now to concentration. Now, so what you need to know importantly is that now, if your soluble substance is dissolved in a solvent, a homogeneous mixture or solution is going to be obtained, right? Now, for example, let's say now I give you the example of your sugar water, right? Your sugar water, right? Others they call it starch water. Now what you need to know is that the more sugar is dissolved, which means now if this is your cup and this is your water, and now the more grains, you are pouring it into this particular cup, right? If you are pouring it into this now this amount of water, in this water, I would get what will happen is basically the more you're going to pour the sugar, right? The more you are going to pour the sugar in here, right? Let's say this is your sugar. Let's use another color for our sugar, right? Now, let's say this is your sugar. You are pouring it. These are your sugar. You are pouring it in the same amount of water, right? So the more you pour, it is going to be now become much more sweeter and sweeter and sweeter, right? Now, which means the more you pour in the sugar here, right? If this is your water, and this is your sugar, right? So if the more now you pour in your sugar, what are you increasing? You are going to increase the sweetness, right? You're going to increase the sweetness of this particular water. Now, the more you increase the sweetness of water, we are saying now you are increasing the concentration of this particular water, right? So you are increasing the concentration of this particular water. So for example, also if let's say you are given, now let me give you another example. Let's say you are given that this, let's write this line to be nicer now. Now let's say you are given that this particular jar, right? This particular jar, it is 4 liters, right? It is 4 liters. It's 4 liters. And now you have your orange juice. Let's remove this so that we draw nicely here. Now you have your orange juice. And now they say now your orange juice makes up to, let's say it makes up to your 7 liters, right? It makes up to your 7 liters. But if you're going to take all these all these two, all, let's say this is our 500 mil. This is 500 mil of your oros, and you are pouring it in this 4 liters. What will happen? Basically, the concentration of this water here, the concentration of this water in here, it is going to increase the more you pour this particular oros in this jar altogether. So, and the more it does so, then we are saying now this is going to be the concentration, and you are going to be increasing the concentration of the water, right? So now, therefore, we are saying concentration of a solution is determined by the number of by the amount of moles or amount of solute in a certain volume of a solvent, right? So in a certain volume, which means the object in which it occupies, right? That is going to determine that. And now, what you need to also know is that in most cases, water is used as what? As our solvent. That's what you need to also know, that your water is going to be used as your solvent. Now, what is it that we are going to do now in order for us to calculate this concentration? Now, let's see. So basically now we are saying concentration of a solution is going to what? Concentration of your solution is the number of moles. It is going to be the number of moles, right? It is going to be the number of moles of a solute, of your solute per unit volume, So basically, that is going to be your concentration. Now, and we have a formula in which now we can use to calculate our concentration. Now we are saying our concentration is calculated, but by what? Now we are saying concentration is equals to N over V, right? So the C, which represent you see, which represents the concentration. And now what you need to know also about the concentration is that it consists of units of moles per decimeter, per decimeter cubed. While now the N, which is a representation of your number of moles of your particular solute, right? So this is going to be the number of moles, and this is the number of moles, and the number of moles is measured in moles, right? And now this is going to be the volume. And now what you need to know that our volume also, it is going to be measured in decimeter cubed, right? Now that is going to be our concentration, or rather that is going to be our volume, right? Now, in other words, what you need to know is, now what you need to take note of is that now, if let's say you are given that you whatever that you are given as terms, in terms of volume, you are given it in terms of centimeters. Your thinking now can be calculated, or rather can be converted into what? Into decimeters, right? And which is can also be converted into what? Into liters, right? Into your liters with your R here, TRE. Now what you need to know is that now if you have your 100 centimeters, now your 100 centimeters represent, or rather not 100, but rather 1,000, it represents 1 decimeter cubed of the volume that it is going to occupy, which is also going to be same as your 1 liters, right? Or rather, which is going to be 1 liter. So now if you are having 1 centimeter cubed, now your 1 centimeter cube, this is going to be your 0.011 decimeter cube altogether. And now also what you need to know is that now 1 centimeter cubed also, it is the representation of 1 milliliter, right? So now these are some of the things that you need to take note of. Now let's see in terms of how can we now go about to try and calculate this concentration. Let's get some examples. Now we are given that now we have a solution, and they say now the solution contains, let's try and get another color here. Now they say a solution contains what? It contains your 10 grams of sodium hydroxide, right? And now in what which is going to be in your 200 centimeter cubed of a solution. Calculate the concentration of the solution. Now what you need to consider firstly is that now what you're given here, it is what we regard as your mass. And what you are given here, it is what we regard as your what? Your volume. And now they want you to calculate your concentration. But now, let's see, if you want to calculate the concentration, you must have the mole and the volume. Yes, you have the volume, but you do not have the number of moles. So which means what is important is now you need to come again and start afresh to calculate what is going to be your moles, and then so that you can substitute in order to calculate for what? For your concentration. Now let's see. So basically now what we are going to do, we're going to start here. We're going to say log calculate what is going to be the moles. We are going to start here. We're going to say now your moles of your your sodium hydroxide, it is going to be given by what? Your moles of your sodium hydroxide, it is going to be given by what? By the mass over your molar mass. And now what you know is that you already have this, because you are given that this is going to be your 10 grams, right? The solution is 10 gram, contains 10 gram of sodium hydroxide. So which means what we are going to do is we are going to say this is going to be 10 over, now what is the molar mass of NaOH? Now what you are going to do is we are going to say what is the mass of your sodium. Now your mass of your sodium is going to be given by 23, plus the one of your oxygen is going to be 16, plus the one of your hydrogen, it is going to be 1. So the totality of all of this is going to be 0.25 mole. Are we together? And now then we are done. At least now we have what? We have the mole. Now let's see in terms of what else now can we do. Now, as soon as we have the mole, now the second part is we can then now come and calculate what is going to be our concentration. But now, for us to calculate what is going to be our concentration, we need to start here. What volume does this particular solution occupies? They said it occupies 200 centimeter cubed of your solution. And now what we know is that now your solution is always measured in decimeter cube. So what we are going to do firstly is we are going to say this 200, we are going to divide it by 1,000 so that we can have it in your what? In your decimeters. So therefore this is going to be same as 0, this is going to be same as 0.2 decimeter cubed, right? And now that we have now the volume, then we're going to come back to this formula and say now your concentration of your NaOH, it is going to be given what is the number of moles. It is going to be 0.25 over what is going to be the volume that it occupies. It's going to be 0.2. So which means now what is going to be the concentration given the concentration that you're going to find, it is going to be 1.25 mole per decimeter cubed altogether. And now this is also the unit for your concentration. Now let's say now this is our second example now, and in this second example they want us to calculate the mass of your solid in 600 centimeter cubed of 1.5 mole per decimeter cubed sodium chloride solution. Now, in this, what is it that we are going to do? We are going to start here. What are we given? So firstly, yes, we have this as our volume, and we have this as what? As our concentration. But now what is important is they want us to calculate the mass, which is your small m, right? Now, what is it that we are going to do? We are going to start here. And now, because we have the volume and we have concentration, then we can start by calculating the moles, right? Because look, isn't it that we said concentration is same as N over V? Now, in this case, now we are given what is our concentration, we are given our volume. But now let's start by working out the volume. The volume you are given that this is 600 centimeter cube, and you can convert this into decimeter cube because that's how we measure our things. So this is going to be 0.6 what? Decimeters. This is going to be 0.6 decimeter. And after that, 0.6 decimate. And then after that, we're going to come back and say now, the mole of our sodium chloride, which is our NaCl, it is going to be given by what? It is going to be given by 0.6 multiplied by your 1. This one, the concentration is given by 1. So this is going to be 1.5. And now to calculate that, what are you going to get as your mole? Now, the mole that you're going to get there, it is going to be what? The mole that we are going to find there, it is going to be 0.9 mole. Now, as soon as we find that particular mole, now we are going to come back. We are saying we are looking for the mass. And now, remember, we know that mole is given by the mass over the molar mass. And yes, we already have the what? Now, let's use another color. We already have this, your moles. And now we can find our molar mass. Isn't it so? Let's try and find our molar mass first. Now we are looking for molar mass of NaCl. So what is going to be your Na? Your Na, it is 23 plus 35.5. Then what is going to be the mole of this? Now this is going to be 58.5 grams per mole, because that's how we measure our molar mass. And then after that, we are going to say, look, now our mass, therefore, it is going to be given by the mole multiplied by the molar mass. And do we have the mole? The mole is 0.9 multiplied by 58.5, right? And therefore, what is going to be the molar mass? The mass, rather, it is going to be same as your 52.65 grams. So basically now this is going to be the mass that we are going to have. And now you see it is very much almost easy to also, when you're given the concentration, to move backward in order for you to solve your solution.